Hi guys, welcome to another lesson of AP Statistics. Today we're going to be learning more on mutually exclusive events, general addition rule, how to make a two-way table, and how to make a Venn diagram from a two-way table. So, in the survey that I posted, 30 students responded altogether. 20 were able to do a taco tongue, and then 10 were not able to do a taco talk. 18 students were able to do the evil eyebrow, and we have 12 who were not able to do it. In the 18 students who were able to do eyebrow, 15 of them were also able to do the taco talk. That leaves us with 3 people who were not able to do taco talk. We have in the 12 students who are unable to do evil eyebrow, 5 of them were able to do the taco tongue. So that leaves us with 7 people who cannot do taco tongue, cannot do an evil eyebrow. Okay? So we have here, we're going to transfer the two-way table into our Venn diagram. I would like to remind you that the first thing that goes in the Venn diagram is the middle number. Okay? When I say the middle number, this is an intersection of both events. So the number that goes here is how many people were able to do taco tongue and at the same time were able to do the evil eyebrow. How many people were able to do both? And that is 15 people, correct? So 15 people were able to do the yes taco tongue and yes evil eyebrow. And because we already have 15 people in the intersection, you need to remember that this whole entire circle right here is a total of everyone who were able to do taco tongue. I will repeat. This whole entire thing is the list of people who were able to do taco tongue. Now, what goes in here? This is the people or the students who were able to do taco tongue but not evil eyebrow. So we're able to do taco tongue, but not evil eyebrow, and that is 5 people. And over here is we're able to do evil eyebrow, but not taco tongue, and that is 3 people. Now what goes in here is everybody else. And how much is everybody else? So we have 3, 5, and so here is 7. So what is 7? 7 is the people who were not able to do taco tongue, who were not able to do evil eyebrow. Does that make sense? Right, let's answer the questions below. We have suppose that we randomly choose a student from class, find the following probabilities. Yes, taco tongue. So the probability that they were able to do taco tongue. The probability that they were able to do taco tongue, that is 20 people out of 30. So you can reduce it, but for now, let's leave it as a reduced fraction. So it's easier to track if we got it wrong or right. Okay, the probability that they were not able to do taco tongue. The probability that they were not able to do taco tongue, that is 10 people out of 30. Moving on to the other side. The probability, I am doing this one right here. The probability that they are able to do evil eyebrow. Yes, evil eyebrow. How many of them? The probability that they are able to do evil eyebrow, 18 out of 30. Next, the probability that they are not able to do evil eyebrow. The probability that they're not able to do evil eyebrow is 12 out of 30. These people right here. Okay, moving on. The probability that they can do taco tongue, I am doing this one. The probability that they're able to do taco tongue And at the same time, they're able to do an evil eyebrow. So the probability that they are yes evil, yes taco. So that is 15 out of 30. Next, the probability that they can do taco tongue, and so and in probability means at the same time. And means at the same time. So they are able to do taco tongue, and at the same time they cannot do evil eyebrow. That is 5 out of 30. Moving on. Yes, evil eyebrow, and at the same time no taco tongue. That is 3 out of 30, correct? Next. No takotang and no evil eyebrow. So this is an intersection between a person that cannot do takotang, but or and at the same time they cannot do an evil eyebrow. So that's the 7 out of 30. Yeah, this is this number right here. These are the people who cannot do any of these. All right, moving on. Suppose that we randomly choose a student from class. Find the following probabilities. Suppose that we randomly choose a student from class. Find the following probabilities. Yes, evil eyebrow. Yes, evil eyebrow. So that's can do evil. So this is just 18 out of 30. It's repeated, right? And the next, no evil eyebrow. Yes, evil eyebrow. No evil eyebrow is 12 out of 30. Now, yes, evil eyebrow or no evil eyebrow. Remember, if you watch the previous video, or means that you're adding both. Remember that? So that means we're adding the people that can do evil eyebrow, evil eye. Can I just put that? Plus the probability of the people that can't do evil eye. Is that everyone? Is that everyone, you guys? That's 30 out of 30. That's everyone, yeah? Okay, this event is called mutually exclusive event. Mutually exclusive events. Why? In the previous video, if you watch the previous video, mutually exclusive events mean that these are the events that, oh sorry, this is in not mutually exclusive. Um, because mutually exclusive events means that they can't happen together. I what am I doing here? I am skipping to number 4 already. Okay, so these are mutually exclusive events. Number 3 is a mutually exclusive event because these are the events that cannot happen together. Because it says, yes, can you do an evil eyebrow and at the same time not evil eyebrow? That doesn't make sense, right? Yeah, so these are the events that cannot happen together. Good. Events that cannot happen together. For number 4, suppose that we randomly choose a student from class. Find the following probabilities. Yes, taco tongue. How many people can do taco tongue? 20 out of 30. How many people can do evil eyebrow? 18 out of 30. Okay? And now we will solve the or. So we're combining everyone that can do taco tongue plus can do evil eyebrow. Okay? Let's do it this way. So I'm combining 20 out of 30. These are all the people that can do taco tongue plus 18 out of 30. These are the people that can do evil eyebrow. But okay, I would like to remind you the difference between number 3 and number 4. In number 3, these are mutually exclusive events. They cannot happen together. But in number 4, this is a not mutually exclusive event. These may not mutually exclusive events. These events can happen together, correct? Can you do a taco tongue and at the same time do an evil eyebrow? I will repeat. Can you do a taco tongue at the same time do an evil eyebrow? Are there students in this class that can do both? Let's check. So we have 18 18 of the students were able to do evil eyebrow. That's this 18. Now we have 20 students who can do taco tongue. This is 20. But there are also students who can do both. But if you notice, the 15 is added in this 20, and the 15 is also part of this 18. So if we add 20 and 18, does that mean we're adding some people twice? I hope you guys are understanding this. So if I'm adding 20 and 18, so you know how earlier I added 18 plus 12, that's okay because these are two separate events. But if I just add 20 and 18, it doesn't make sense anymore because I'm adding some people twice. So the formula in here would change. We need to subtract all the people that were able to do taco tongue and at the same time evil eyebrow. So I have to subtract 15 out of 30 in this equation. Now the formula we changed from P of A plus, oh wait, sorry. Let us, from P, A, or B, the formula is really just P of A plus P of B. If they are mutually exclusive events, if they can't happen together. But if they can happen together, then the formula for OR now changes into P of A plus P of B minus, we are subtracting the AND portion. We're subtracting the two things that are happening together. Is that making sense, you guys? Okay, let's have another example. But before that, let's complete the two ideas section, our important ideas. So to make a two-way table, right? Let's do a table. So this is A, not A, B. Oh, wrong side. I have extra box. And this is B, not B, or complement of B. So let's put 1, 2, 3, and 4. And we are putting that into a Venn diagram. And remember, a Venn diagram has a number on the outside of the circles. We call that one whatever is not part of the circle. Yeah? So take a look at where I put the number. Whatever the number that goes here goes in the middle. Whatever pink is goes over here. And then whatever green is goes here. And whatever 4 is goes here. All right. So now we have what we call the general addition rule. General addition rule would be P, A, or B is equal to P of A plus P of B minus A and B. So the combination of both of them. Okay? If events are mutually exclusive, or if events A and B are mutually exclusive, they can't occur together. So the formula would be, oh, when the formula for mutually exclusive events is P of A and B equals 0, meaning if they're mutually exclusive events, then that means they can't happen together, so they should have no intersection points. Okay? And so when that happens, the formula for A or B is just P of A plus P of B. You don't have this part right here because they are mutually exclusive event. They cannot happen together. That means this formula only applies if they are not mutually exclusive events. Okay? Let's see if we can apply the same thing in here. A random sample of high school students were surveyed regarding their toilet paper habits. Should the toilet paper pull over the roll? Do they replace the roll when it's empty? The two-way table displays the data. Suppose we choose a member of the sample at random. Define events O. O means over and R means replace. So, replaces the roll when it's empty. Yes or no? Prefer the toilet paper to pull over the roll. So let's put the total first. 58 plus 24, 82, 12, that's 34, that's 116, right? So 58, that's 70, 24, that's 46. Okay, and again, that's 116. Explain in plain language what P of O with a C on the top. And I am hoping that you've already watched the previous video so you know what C means. And find the probability. So do you remember O means over, right? Okay, and do you remember what C means? C means the complement of, right? That's meaning not O. So let's put that in. We have P of. Okay, I'm hoping that you guys, for now, pause this video and then do it on your own all the way to letter D and then come back after you're done. Okay, I'm hoping that you actually paused the video. So let's do this one to check your answer. So P of O with the C on the top is the probability of choosing a student who does not prefer toilet paper to pull over the roll. Okay? And what's the probability of that? Not O. That means everything that is not O. Okay? And that is this group of people right here. Yeah? Because these are the people that prefer the toilet paper to pull over the roll. These are the no people. So that is 46 out of 116. So what's 0.3 or 40%? Explain why P of O or R is not equal to P of O plus P of R. Then find the probability of O or R. Okay, I hope you guys are not going to get confused on this one. First, let me direct you to the answer to this one so you don't get confused. What's P of O plus P of R? Okay, so let's put everything P of O plus R. That means I would add all of the O and all of the R, correct? But when I say O or R, does that mean everybody that is O plus everybody that is R minus everybody that is O and R? So if I follow the formula on the top, that makes sense or not, you guys? Okay, so the events, let's put that in a word. Over the roll and R mean replace, yeah. Replace when empty are not mutually exclusive, meaning they can happen together because we do have an and right here. This 58 people is a yes and a yes. Not mutually exclusive, meaning the formula would be P of O or R is equal to P of O plus P of R minus P of O in the R. Okay, let's color that different. So how many are P of O prefer to be over the roll? That's 70 out of 116 plus people who replaces it when it's empty, all the yeses. That is 82 out of 116. But okay, here's what I'm trying to do. This 58 people is added in the 82, correct? This 58 people also is added in the 70. That makes that doesn't make sense, right? If we just add the 70 and the 82, that means we're adding these people twice. And so, in order for us to avoid adding those people twice, we need to subtract that into our equation. So our answer here is 94 over 116. Make a Venn diagram to display the sample space of this chance process. So let's make a Venn diagram. The Venn diagram should not be hard for you guys because I put that on the top already. Okay, so this is over and this is replaced. Remember, when you do a Venn diagram, you do the middle first. How many people is over, yes to over, and yes to replace? That's 58 people. And everybody that said that the yes to replace is 82. But then because we already have 58, then that leaves us 24 on the other side. Everybody that says over the toilet is 70, but I already have 58 in the middle, so that leaves me 12 in there. And this 22 people are the no over the roll and no replaces the roll when it's empty. So that is your Venn diagram. Write the event does not replace the roll and prefers the toilet paper pulls over the roll in a symbolic form and find the probability. Does not replace. So R complement and O. So these are the people who does not want to replace. Let's look at the, so it's not O and at the same time, sorry, it's not R at the same time it's an O. It's not R at the same time it's an O. Is that 12? Right? Let's delete this one right here. Is it not 12? The people that is no to replacing but yes to over the roll. So that is 12 out of 116. Okay? Thank you guys for listening. I hope that you guys, it's kind of it's kind of confusing, I know, because there are so many equations and notations involving in it, but hopefully you guys are understanding this. If you have any question, let me know. Thank you guys.